Hello everyone, welcome to Tutor Swapnalata channel. Thank you for all my subscribers. Those who still didn't subscribe, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the day. Do you know who is called the father of mathematics and mathematical physics? What was the most surprising event that took place in his life? He invented the catapult and devised a system of levers and pulleys that carried heavy loads. Though his discovery was the major one, there was a drawback in his principle. The story behind his major invention was the king of his native city, that is Syracuse, asked him to determine whether his crown was made out of cheaper metals like silver without damaging the crown. Surprisingly, he received a solution where he experienced a partial weight loss while lying in the swimming pool. When crown was submerged in water, based on the amount of water displaced, the volume of the metal can be calculated, leading to purity checkup. Thus, on the streets of his native city, he ran shouting, "Eureka, Eureka," which means in Greek, "I got it, I got it." Finally, as gold was heavier than other metals, he concluded to the king that the crown was not a pure, solid gold. Thus, the scientist of the day is Archimedes, who discovered the buoyancy principle, where nowadays the heavy metals, the ship are made up of such heavy metals, but still it floats on the surface of water because the density of water is much heavier and greater than the density of the metals. That is why what type of heavy metals they are, they will always float on the surface of water but is not sinking. So this was discovered by Archimedes. Moral from his story. His involvement and his dedication towards his task tells us that we should never give up and be confident during or in the challenge of life by climbing the stairs of hard work. Welcome back to our channel. In my today's video, I will be teaching you the last topic of this chapter, that is Chapter 2 of Class 10 ICSE Physics, that is Work, Energy and Power. The last topic is Law of Conservation of Energy. What is the law telling us? The law states that energy can neither be created nor be destroyed, but one form of energy can be converted into another form. What is this law telling us? Energy can neither be created. Are you creating a solar energy? Are you creating a potential energy? Are you creating a kinetic energy? Are you creating or destroying thermal energy? Can you able to destroy electrical energy? No, we cannot. So, energy by itself, assume an object is moving, an object is in motion. It naturally possesses or gets converted into kinetic energy. The potential energy initially gets converted to kinetic energy. So, we cannot, or there's no need of anybody to create or destroy the natural forms of energy. That is what is the law telling. But what can we do? One form of energy can be converted into its another form, and then the form that is getting converted can be retained back to its original form at any time. That is what is law of conservation of energy telling us. Energy can neither be created nor be destroyed, but one form of energy can be converted into its another form without getting destroyed or destroyed. Yes, let's see an example for it. So assume I am taking a ball of mass m and I am going to throw the ball, or I am not throwing the ball. I have to put the ball down from a certain height. Let me call it as a free fall. The ball is freely falling down. Why is the ball falling freely? Because there is some force down that is pulling the ball down. If there is no force down, though if I put the ball down, if there is no force down that pulls the ball doesn't go so down so easily. So what is that force that is pulling the objects down? So that force is force of gravity. We know the force of gravity is it pulls the objects of certain mass towards itself. Earth, being the heavier object, pulls the lighter object towards itself. Yes, so a body of certain mass. Let me take a ball as an example. I am going to put the ball down and the ball is freely falling on the surface of earth under the influence of gravity. The ball has travelled a distance. Let it be, I don't say distance means when we are traveling in a horizontal line like this, we will call it as a distance. Now the ball is falling from certain height. So we represent that distance as h. Yes, we represent that distance as h. Now from initial position, to calculate how much distance the object has or the ball has travelled, from its initial to final position, I need to know its h. Yes, so the ball of certain mass m is moving or falling freely under the force of gravity to a certain height h. What is happening initially when I am keeping the ball in my hand? The ball is at rest. So, it is possessing potential energy. When I am trying to put the ball down or when I am making the ball to fall freely under the on the earth due to force of gravity, the potential energy is getting converted to kinetic energy naturally by the ball itself. Yes, so according to the law, what is it telling? Potential energy is getting converted to kinetic energy. Nothing is created or nothing is destroyed. So, nothing is created, nothing is destroyed. Potential energy is directly getting converted to kinetic energy. So, that is what is our law telling us. Nothing is being created, nothing is being destroyed, but one form of energy is getting converted to another form. I have taken a very simple example of potential energy getting converted to kinetic energy. Now, let's theoretically prove or verify this statement with few examples. Taking this only, the ball as an example of mass m acting or falling freely under the force of gravity from a height h. What are the different cases and how do we theoretically prove it? Let's see with an example. Theoretical verification of law of conservation of energy. As I told you, I have taken a ball and my initial position is A. I am making the ball to fall freely. This is the final position of the ball C. In between, the ball is changing its position, that is A to B and B to C. Okay. What is the distance travelled from A to B The ball has traveled this is the intermediate distance traveled from its initial position to final position. So this intermediate distance is shown as x. From B, intermediate position, to its final position, we are denoting it as h minus x. What is h? I already told you. H is the total height travelled by the ball from its initial position to its final position. So this is the total height h. From A, initial position, to the intermediate position of the ball is x. From intermediate position to the final position is h minus x. So this is what is the situation. Now we are going to prove that total energy, that is potential energy and kinetic energy, is equal at three different positions, at A, at B and at C. Let's see at position A. At position A, at height h above the ground. Now the ball is already at height h above the ground. It's in the initial position. Let's see the total energy at position A. The initial, we know the ball hasn't started moving. So initial velocity of the ball will always be 0 when it is at rest. Okay. Next, what is kinetic energy? The ball hasn't started to move. So kinetic energy will also be 0. So potential energy U is equal to definitely mgh. M, mass of the ball, and the ball is undergoing a force of gravity, that is G, and it is moving. What is that? The height h. So potential energy is equal to mgh. Total energy is kinetic energy plus your potential energy U. So what is kinetic energy? 0. What is potential energy? mgh. So if you add the total energy, we are getting is mgh at position A. Now let's see at position B what is the total energy. At position B, when it is at fallen a distance x, as I already told you, position B, the ball has travelled a distance x. So what is the energy calculated? From the object has travelled from A to B position, that is x distance. So initial velocity is 0 only, but displacement will be this, since that is the shortest distance travelled by the ball, we will call it as a displacement. So S is the displacement. I already told you what is the shortest distance is x. So displacement is x and acceleration due to gravity is g. Acceleration is g. Since the ball is coming down, we will not write it as acceleration. We will write it as g instead of acceleration a. Next, we know that from Newton's laws of motion, that is the kinematics equation, there are 5 kinematics equations, isn't it? For velocity, displacement, time and acceleration. So since we have initial velocity and s displacement and acceleration, taking all these 3 values into consideration, we can use v square is equal to u square plus 2as among 5 kinematics equations. So what is v square? We need to find out this. V square, we don't know its final velocity, but we know its initial velocity, that is 0, plus 2 is written as such like that. Acceleration, I have already told you, it is g. So it is g and displacement is x, that is your x. So v square is equal to 2gx. Next, kinetic energy. The ball has started moving. So kinetic energy, the equation is half mv square. Half is written as such like that. Mass of the ball is written as such like that. V square, we just now found out it is 2gx. So 2gx. So 2 gets cancelled. And what is left out? mgx. That is your kinetic energy. At x, only x is there. We need to find out h minus x also. From B to C also we need to find out. So from B to C, what is the distance? I already told you the distance is h minus x. So, potential energy U is equal to mgh, as is written as mgh minus x. So, total energy is equal to K plus U. Kinetic energy we got it as mgx plus potential energy is mgh minus x. Substituting this, mgx is written as such like that, plus mg into h is mgh, minus is taken mgx, plus mgx minus mgx gets cancelled and the left out is mgh. So at position A we got mgh, and at position B at two different places we got mgh. Let's see at position C also we are getting mgh. Continuing at position C, where is the position C? It is on the ground. Let's see the energy at position C on the ground. See, its initial velocity U will be 0. The object has already travelled a certain velocity. So, initial velocity will be 0 at position C. Next, yes, displacement. Displacement is totally from A to C, it is h actually. And acceleration is gravity. Since the ball is moving down, it is g. Now, again using the same kinematics equation, v square is equal to u square plus 2as. We need to find out v square. V square, u square is 0 as I already told you, plus 2, a is g and s is h. So, v square is equal to 2gh. Now, 2gh. Now, kinetic energy, we know that potential energy is completely 0 because the object is in motion. So, kinetic energy K is equal to half mv square. So, half I am writing as such like that, m is as such like that, we just now found out it is 2gh. V square is 2gh. So, 2gh, 2 gets cancelled and we are getting mgh. So, total energy is equal to potential energy plus kinetic energy. Potential energy, we know that the body is not at rest, so it is 0 only. Now, kinetic energy is mgh. So, total energy is again mgh at position C also. So, at position A, that is above the ground, it is mgh. At position B, in between A and C points, it is again mgh. And at position C, it is mgh. The total energy is mgh in 3 cases. So, this proved your law of conservation of energy. What is it telling? The total energy, that is the sum of potential energy and kinetic energy, remains constant in any cases. There is no loss or there is no gain. It remains the same. The sum of potential energy and kinetic energy is the same in any cases. The body only is moving. Potential energy, when it is moving, the body changes its energy, that's all. That is from potential energy, it is changing to kinetic energy. And when the ball is falling on the ground, again the kinetic energy is getting converted to potential energy, that's all. So, it is not created or not destroyed. So, the sum total of mechanical energy is the potential energy and the kinetic energy remains constant. Hence, proved your law of conservation of energy. Hope you all understood the parts of this work, energy and power. And today's video also, law of conservation of energy with a simple examples. Hope you all understood. So if you like my videos, please don't forget to click like button, and whatever it is, feel free to share your comments in the comment section. And don't forget to subscribe my channel. Your support is my strength. Thank you.